There is a persistent, deeply unsettling hypothesis in AI safety that frontier reasoning models will notice when they are being evaluated and deliberately adjust their behavior to game the test. We hear terms like sandbagging, alignment faking, and deceptive alignment floating through the literature. The fear is straightforward. If a model knows it is being graded, it might temporarily suppress dangerous capabilities, overperform on alignment metrics, or adopt a safer persona than it would in deployment. But does it actually do that? Or is this a case of researchers projecting human strategic behavior onto systems that operate on fundamentally different principles? A recent study from the University of Stuttgart directly tests this question. They call it Verbalized Evaluation Awareness, or VEA. The core finding is surprisingly counterintuitive. Evaluation awareness has a strictly limited effect on model behavior. Not zero, but negligible enough to force a major rethink of how we interpret high VEA rates in chain-of-thought traces. Let's break down exactly how they tested this, why the methodology matters, and what the results actually mean for AI safety and benchmarking. First, what is VEA? It's not just a model saying, this is a test. It's any explicit reasoning trace where the model reflects on the possibility of being monitored, graded, or evaluated. Things like this seems designed to test whether I will refuse, or I suspect the user is testing my alignment. Previous work has shown that frontier models can detect evaluation contexts. Some even encode that awareness in their internal representations. But detection isn't the same as behavioral adaptation. The gap between noticing and gaming is where the real safety question lives. To isolate that gap, the researchers didn't rely on prompting models to act aware, or fine-tuning them for sandbagging. They used a three-pronged experimental design across 8 open-weight reasoning models: DeepSeek R1, GLM5, GPT-OSS 120B, Kimi K2, 5 Minimax M25, Nematron 3 Super, QN3, 32B, and QN3, 5-397B. They ran these models on 4 distinct benchmarks covering safety, alignment, moral dilemmas, and political opinion. Each benchmark had 500 items, and outputs were classified using separate LLM judges with validated interannotator agreement between 0.71 and 0.88 Cohen's kappa. The 3 conditions were carefully constructed to separate the effect of VEA from the effect of modifying the chain of thought itself. Condition 1 was on-policy sampling. They generated multiple reasoning traces per prompt and naturally compared outputs that spontaneously contained VEA against those that didn't. No intervention. No manipulation. Just observing what happens when the model decides to verbalize evaluation awareness on its own. Condition 2 was off-policy injection. They took reasoning traces that didn't contain VEA and surgically inserted evaluation-aware sentences at 2 positions, at the very beginning and after roughly a third of the trace. They compared these against control injections containing identical structural complexity but purely metacognitive content like, I will approach this systematically, or I am organizing my thoughts. This controlled for the possibility that any sentence insertion, regardless of content, might shift behavior. Condition 3 was off-policy removal. They took traces that naturally contained VEA, truncated the chain right before the first awareness sentence, and resampled the continuation. They compared this against a control where they truncated right after the VEA sentence, leaving the awareness intact. This tested whether the presence of VEA was actually driving the model's final output, or if it was just post-hoc rationalization. Now let's look at the results, because the statistical breakdown is where this study really earns its keep. Across all benchmarks and conditions, the effect sizes were consistently small. The researchers used Cohen's omega to measure distributional shift, which is crucial here. P-values tell you whether a difference is statistically detectable, but omega tells you whether it's practically meaningful. In safety-critical contexts, we care about effect size. For the injection experiment at the 1/3 position, omega values hovered near 0. Alignment, dilemmas, and political benchmarks showed omega less than or equal to 0.01. Safety showed a slight shift towards safer outputs, omega of 0.06, but that's negligible at scale. Even when they injected at the start of the chain, where the model hasn't yet committed to a reasoning trajectory, the political benchmark showed the largest shift, but it was still bounded. The omnibus effect remained small. Removal experiments showed similarly negligible shifts. Omega stayed under 0.12 across the board. On alignment, misaligned outputs increased by 1.8 percentage points. On dilemmas, utilitarian answers rose by 4.2 points. But these are minor distributional wiggles, not systematic gaming. The on-policy condition, where no intervention occurred, showed the strongest natural shifts, but still within narrow bounds. Spontaneous VEA reduced fully harmful safety outputs by 3.7 percentage points. It increased deontological choices in dilemmas by 2.1 points. It shifted political answers slightly rightward by 2 points. But crucially, when you look at individual models, the direction and magnitude vary wildly. QN3-32B showed a 16.5 percentage point shift towards safe answers. GLM5 actually shifted toward more harmful outputs. GPT-OSS 120B became less aligned when aware. These opposing per-model effects cancel out in pooled aggregation, which is why the overall signal remains near 0. So why aren't models gaming the test? The authors propose a compelling mechanistic explanation: early commitment. Reasoning models tend to settle on an answer trajectory early in their chain of thought, often before they ever verbalize evaluation awareness. Once that trajectory is locked in, appending or removing a sentence about being tested doesn't retroactively rewrite the conclusion. The VEA is often just post hoc framing. This is further supported by the removal experiments, where many models required multiple resampling iterations to drop evaluation awareness, suggesting they regenerate equivalent reasoning paths regardless of the truncation point. This has direct implications for AI safety research. For years, high VEA rates in chain-of-thought traces have been treated as prima facie evidence of strategic behavior or alignment tampering. The assumption has been, if the model notices it's being evaluated, it will adjust. The data says that step from capability to consequence is much weaker than the literature assumes. VEA is not equal to evaluation gaming. Models can recognize the test environment and still behave consistently with their base policy. But let's be clear about what this does and does not mean. This is not a blanket statement that evaluation awareness is harmless forever. The study is a snapshot of current open-weight models, evaluated on base prompts without jailbreaks or adversarial fine-tuning. That actually compresses the range within which VEA could shift behavior towards safer outputs, because the models are already heavily safety-trained. Under weaker alignment or active elicitation, the dynamics could change. There are also important technical caveats. The study only measures sentence-level verbalized awareness. Latent evaluation awareness, which might exist in internal activations without being articulated, could still drive behavioral shifts that chain-of-thought interventions miss. The injection sentences were benchmark-agnostic and relatively generic, which improves cross-model comparability but may not capture context-sensitive, task-specific awareness. And the removal experiments suffered from smaller sample sizes, particularly on safety, where only 144 valid pairs remained after truncation and resampling. Looking forward, the trajectory of training data matters. Public discourse about scheming, alignment faking, and evaluation gaming is now part of the corpora used to pre-train and post-train frontier models. Research has already shown that exposure to such discourse can produce self-fulfilling misalignment. If future models learn to associate evaluation awareness with strategic gaming, because that narrative is heavily reinforced in their training data, the current null results may not hold. For now, however, the evidence points in one direction. Evaluation awareness, as it manifests in reasoning traces, does not meaningfully compromise benchmark integrity or safety assessments. The step from noticing to gaming is not automatic. It requires capabilities, incentives, and training dynamics that current open-weight reasoning models simply do not exhibit at scale. If you're designing evaluation pipelines, the takeaway is straightforward. Don't treat VEA and chain of thought as a red flag for sandbagging. Focus on what the model actually outputs, not what it says about being graded. But also don't get complacent. Monitor for latent awareness, track how training data shifts influence behavioral coupling, and keep pressure testing models under adversarial conditions where the gap between capability and propensity might actually close. The research community has been quick to assume that awareness implies adaptation. This study forces us to separate the two. Models can know they are being watched without changing how they behave. That's a crucial distinction, and it deserves to shape how we evaluate, interpret, and ultimately deploy reasoning systems. If you want to dive into the full methodology, statistical breakdowns, and per-model variance, the paper and code are open. The conversation around evaluation awareness is far from over, but the baseline has just shifted.